So hey guys, welcome back. This is Abhishek, and today in this video I will be going to take a walkthrough of a project which I recently made. And this is a social distancing tracker. So this is really very useful. We can implement this such project with a CCTV camera in a very crowded place or mall or shopping complex, wherever we want. So you can see that this is running on my CPU, and the weak CPU, that I would say that weak CPU because my CPU has the 2.50 gigahertz of frequency. So that's why I'm saying it's a weak CPU, and I'm almost getting a 6 FPS. That is not that bad. So what is here, so you can see that this is the person detected right now in the current frame, and this is so violation, that how many people are violating social distancing. So let's understand that how I build this code. So this is really easy to understand, and the first thing first, I will tell you that this is not GPU computer. So if you have CUDA supported computer, you must go with Yolo advanced version. So if you use Yolo object detection architecture advanced version, you will get definitely more accurate result. So let's get started. So first thing first, I have imported CV2 because for all the bounding boxes and detecting everything, I will be using CV2 for that. And NumPy, again, if so obvious, that is important. So importing time. So why do you need time in this project? Because we are going to calculate FPS, and that's why we need time as well. So iter tool from import combination. I am importing iter combinations from iter tool, and if you don't want to use iter tools, so or combination, you can definitely go with nested if conditions, nested for conditions. Basically, if we are talking about combination, you can definitely go with nested for conditions. So that will do the same thing. For example, like suppose we want to create a combination of two in a list. So what we do is we create two loops, two for loops, that for x in this list, and again in nested if for y in this list. So this creates a combination. So in that way you can achieve the same working of the combination. So but for the simplicity, to save some few lines, and that's why I'm using combinations here. So here we have two type of tracker. Basically we have to track the object so that we can assign them a id, and then we can calculate the distance between persons, and for that reason I'm using a tracker. So what we have here two type of tracker. The first one is centroid tracker, and the second one is Euclidean tracker. So you can see that I have created centroid tracker.py. So this is all code which I made for tracking centroid. How does this work? what what the whole centroid tracker does is it track the centroid and taking the three reference points. So if our centroid move coordinate to coordinate, it will keep assigning with the same id. It will not change the same id of that centroid. So this is what centroid tracker does. It will keep tracking that centroid, and the condition is that if the centroid moves by using this threshold, if the centroid moves per frame by this threshold, it will have the same id, and that is what centroid tracker does. So this is whole code. I have just shown you a very basic idea behind the centroid tracker. So we have the second tracker, that is our Euclidean tracker. Right here you can see that. So this also does the same job. This also tracks the center point. So I have also tried to implement this centroid tracker in this project, but that didn't perform well. So that's why I'm not using centroid tracker. Instead of that, I'm using Euclidean tracker here. So I'm just calling this Euclidean tracker class here, and then I'm also using non-max separation fast. So does what non-max separation does in OpenCV AI? Whenever we study AI and OpenCV, what we find that whenever we detect some object, right? It doesn't matter what architecture you are using. It could be Yolo, it could be mobile net SSD, or something else. You find that multiple boxes around the same object, right? So suppose you want to detect a phone, and suppose you are using any algorithm like Yolo, and what you find that there is multiple bounding boxes around the same object, and that is what non-max suppression does is non-max suppression remove all the overlapping boxes, and it leave that only bounding boxes having the maximum possibility of detecting that object, maximum possibility of detecting that object. So here you can see that I'm using Yolo tiny weight since my CPU is weak, and that's why I'm using Yolo v3 tiny weights. And I also tried to find out mobile net SSD, but that didn't give me that much accurate result, and that's why I'm decided to go with Yolo v3 tinies. So here you can see that I'm just using Coco names so that I can find I can make a list of having all the classes. So basically we will get, there is almost 80 names in Coco dot names. So here output layers get connected. So this is what is the output layer of Yolo here, and I'm giving a video here. The video name is vts.avi. Let it go. Okay, so for that I'm just starting time equal to time dot time, because I want to capture the number of frame and the second, and that's why we have to start the timing. So this is frame num. Since we have, for now we have 0 frame, and it will be keep increasing as we move frame by frame. So here centroid dict, I'm creating a dictionary of centroid dict, and this whole code is for object detection. So if you haven't done Yolo implementation for object detection, I encourage you to go and check that out, my previous video where I have just shown you that how to implement Yolo on your computer to detect a certain object or custom object. Even you can train Yolo on your custom object. Okay, since we are only interested to detect the label having the person, because we want other object to be detected in rather than a person, so that's why I'm creating a center list, and so that's why I'm appending the center of every detected person. And then also I'm just appending the coordinate of that rectangle. So that's why this is rects. Here bounding boxes I'm converting into np.array. So this is basically not important because we are not going to pass this in NFS for now. So here boxes id is equal to tracker dot update. So this is the way to update our tracker, so it will keep tracking our coordinates according to IDs. So for box IDs and boxes IDs, you can see that cxcy is center of the point, and the centroid dict is, I recently created the centroid dict just to track ID and their center and their coordinate of their rectangle. So I have also created a dictionary, and that is a red zone dictionary. So whatever ID will be violating our social distancing, I will append that in our red zone. So this is really very simple. And then I'm also trying to calculate the distance of every point by taking the combination of two IDs. So means I will be calculating the distance of two person. So taking in a pair, I will be calculating the distance, and then creating a center point as well. So this is here np dot square root of dx square plus y square. This is the rule how we calculate the distance. And then I'm just giving a threshold here of 70. This is actually the pixel width, so it depends. I must encourage you to tune this up according to your camera perspective, or you can either use a bird eye view where you don't need to put some threshold values, and that is much I would say much accurate and much more efficient in the bird eye view. But right now we are not going to use bird eye view. Okay, you can also use deep sort algorithm for tracking the object, and that is much better way to track object. And I will be talking about deep sort algorithm in the next video. So here you can see that if ID is not in red zone, I will be appending that in red zone and giving the center pair, so that we can draw a line between two bounding boxes if they are really very close. And then if id2 is not in red zone, if they are not in red zone, I will be just also appending that in red zone. If they are already not in red zone, they must go in red zone because the distance is less than 70. And then I'm iterating over, if id in red zone, then the color of rectangle would be red, and I'm also drawing a line in between two red bounding boxes, whoever is violating our social distancing. So else we would have a green rectangle, and then I'm also, this whole code is just for some alignment of text, because I'm aligning this whole text using get text size, so that sometime if you are completely free to use other video of having different frame size, and the text alignment will not disturb, because I have made a very dynamic coordinate system where where it doesn't matter which frame size you are using, your coordinates will not be destroyed or not be disturbed. So here I am giving it the status, and now I'm also calculating the number of frame after each frame done. So you can see that, and at the end we are closing it up by using Q button. If you will press the Q button, the whole window will be closed. So if I run this, you will see, and if I want to close this up, so you have to just press Q and it will be closed. And there are so many improvements you can do with this project. The first one is you can convert the whole distance. You can convert the whole calculating of distance using bird eye view. The things that you use and the GPS system, the bird eye view, that and what I'm talking about. So that is the bird eye view. And the second thing is you can definitely use a CUDA supported computer and use Yolo v4 or Yolo v5, and that has a better accuracy. And the third thing is you must use a deep sort algorithm to track the object very well. And sometime what we see in this project, sometime the bounding boxes around a person get disappeared, but that won't happen in deep sort algorithm. So thanks for watching this video, have a nice day.